A very good morning to Dr. Fadli. And today our group would like to present our project, which is BNR 21703 microprocessor and microcontroller. Our title of our project is Project Multifunction Microcontroller System, and we are from Group 1. So there are 5 members in our group. The first one is me, Chen Wanwen. Second, Lee Xin Yi, Muhammad Rifki Zaini bin Ramli, John Uzi Uzaimi bin Mayau, and Muhammad Afiq Irfan bin Sharuniza.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Rifki Zaini Beramli dan nombor kad matrik saya CM220338. Kita terus pergi kepada introduction. So the multifunction microcontroller system project aims to design and implement a versatile electronic system using the PIC 16F877A microcontroller and assembly language programming. The system will incorporate a 7-segment display and LEDs to provide various functionalities based on the group number. The project will involve the development of 2 programs, a main program for keypad operating and an interrupt service routine ISR program for LED controlling using a push button as an interrupt source.
So for the part of division task, me, Wanwen, will be in charge of the simulation result and system programming. Sinyi also will be in charge of the simulation result and system programming. For Rifki, he is in charge of system programming. John is for the description of project, and Afiq is for the system flowchart.
Now, I will present the description of our project. Our project aims to create a multifunction microcontroller system using a PIC 16F877A microcontroller and assembly it in a language programming. It will include a 7-segment display and LEDs to offer different functionalities based on the group number. 2 programs will be developed. The first one are for the keypad operation and the second one are for the LED control using a push button as the interrupt sources. Next, I will explain the key features and function in our system. There are 6 main parts, which are first one, the microcontroller. It is the core component of our system. And the second one are the assembly language, the programming language. It will be used for low-level control and direct manipulation of the system. The third one are the system initialization. This includes the 7-segment display to show up the group number and the LED, which are controlled by the group number. The fourth one are the program development. 2 programs will be created, which is one for the keypad operation and the second one for the LED control using the push button. And the fifth one are the main program. The main program handles keypad input and output, while the ISR program controls the LED. And the main program principle are the 6 main key features in our system, which is the main program uses specific pins to interact with the keypad and display the group number using the 7-segment display. Next, the potential application of our system in real life. The first one are for educational project. This system can be used as a practical learning tools for students studying microcontrollers and assembly language programming. The second one are embed system development. Our system can serve as a foundation for creating more complex embed system with user interface, digital I/O and interrupt-based control, and many more. The third one are for control system. Our system are adaptable for control and automation application that require keypad input, digital input, digital output, and interrupt-based control. And the fourth one are prototyping. Our system provides a platform for testing and validating microcontroller-based functionalities and concepts. And for overall, our project aims to create a versatile electronic system using the PIC 16F877A microcontroller and assembly language programming that includes a 7-segment display and LEDs to offer different functionalities based on the group number. This system finds application in education, embed system, control system, and prototyping.
Okay, hello, my name is Muhammad Afiq Irfan bin Sharun Nizar, and I will present about the flowchart. Okay, for first one, which is the on the left. Okay, first we start with start. Okay, and then the process is display 01 and LED lamp 1 on. Okay, for the input or output, RB0 and RB1 is the output, RB2 and RB3 is the input. And for the port, and then next is port C LED output is the output. Okay, next, for the process, we have keypad input or output patterns. Okay, for the first one, if the key one press display, uh, it will display 11. If key two press, it will display 11 and 22. Next is for the key 3. If key 3 is pressed, it will display 11, 33, and 55. Um, and lastly, for the key 4, when it pressed, it will display 11, 33, 55, and 77. Okay, and lastly, we'll go for the B. Okay, for B, uh, for the process, we have B is for the interrupt process. Okay, interrupt, which is LED input and output patterns. Initial state of all LEDs on or the last interrupt state. Okay, for the first one, for interrupt one, we have LED 6 and LED 7. It will blink two times. Next, for the interrupt two, um, LED 0 and LED 1 and LED 2. It will blink two times. And next for the interrupt 3, um, we have LED 0, LED 1, LED 6, and LED 7 that will blink two times. And lastly, for the interrupt 4, um, we will get LED 0, LED 1, LED 5, LED 6, and LED 7 will blink two times. And lastly, is N. Okay, that's all for the flowchart. Okay, thank you.
So now is for the part of demo and explanation of the simulation results. So for the part of simulation result, the first part is for the 7-segment display, which is also known as keypad code. So this displays group number in 2 digits format, and it is connected to port C. So from the previous demo video that we had done in the simulation in the Proteus app, from this slide we can see this picture. When the simulation starts, if no key is pressed, the number 0 and 1 is shown in the 7-segment display, which indicates our group number. So in this second picture, shown that when button 1 is pressed, the number 11 is displayed on the 7-segment display. LED 1 is in on condition due to no break occurring. So heading to the next slide, we can see that these two pictures, when the button 2 is pressed, the numbers 11 and 22 is appeared. Since there is no break, so LED 1 is still lights up. So button 2 indicates that it will produce two type of output number. For this next slide, you can see on this three image that show that three numbers 11, 33, and 55 were shown when the button 3 was pressed. Since there is still no break, so LED 1 is still on. So we can see that when button 3 is pressed, three types of number outputs were produced. For this next slide, four sets of numbers, which is 11, 33, 55, and 77 were displayed on the 7-segment display when button 4 was pressed. And LED 4 is still on because there is no any break circuit happen that will cause interruption, which is the ISR.
I'm Lee and I'm going to present the simulation result of LED. The LED will turn on according to the group number. For the simulation result, when the simulation button is on and the simulation start, so LED 1 is on because there is no interrupt. As you can see in the red circle, the LED 1 is turned on. When button 1 is pressed, interrupt 1 occur in the LED 6 and 7, and this will lead to LED blinks 2 times. After that, all the LEDs will light up. As you can see, in the red circle, the LED 6 and 7 is light up. Interrupt 2 occur when the button 2 was pressed. Therefore, the LED 0, 1 and 2 will blink 2 times. Then all the LEDs light up. As you can see, in the red circle, the LED 0, 1 and 2 light up. The third interrupt occurred when button 3 was pressed. So LED 0, 1, 6 and 7 blink 2 times. After the interrupt process, all the LEDs will turn on again. The red circle shows that the LED light up, which is 0, 1, 6 and 7. When button 4 was pressed, interrupt 4 occurred and the LEDs 0, 1, 5, 6 and 7 blinks 2 times in the circuit. Then all the LEDs light up again. As you can see, the red circles shows that LED 0, 1, 5, 6 and 7 lights up.
So our presentation has come to the end. Thank you.